Okay, I'm going to be doing a video here today on RIP for you guys, basically to demonstrate the main difference between RIP version 1 and RIP version 2, and that is that RIP version 1 doesn't support classless networks, whereas RIP version 2 does. If you don't know how to address using VLSM, I'm possibly going to do that as my next video. So this is the addressing scheme that I've come up with using VLSM, and that's what we're going to use to configure. This is just a addressing scheme, a classful network using a mask of class C, which you can check out all these little details down there, but we're going to be configuring using that. You don't need to understand exactly how to VLSM yet, you just need to make sure you know that RIP version 1 supports classless, RIP version 2 supports classless, and RIP version 1 doesn't. So I'm going to go ahead and configure this. Okay, so we got 192.168.1.1, mask of 128. Oh. So that's this addressing here. Give it its way out, 16.2. Okay, so you can see with that mask of 128, that's the first bit in that fourth octet has been turned on, which is the 128 bit. So that gives us our network, gives us 128 addresses, 126 usable. You always minus 2 from the subnet because obviously one's the network address and one's the broadcast address. So I'm going to go into this router, start configuring these interfaces, this fast Ethernet and this serial interface here. So enable conf-t, get that out of the way, interface FA0, this is its way out, IP address 192.168.1.2.255.128. No shut, bring it up. Interface SE000, which was the serial, this serial interface just here. Address 192.168.1.193. So this is the way you subnet using VLSM is you kind of go from the highest amount of hosts you want to the lowest amount of hosts you want. So this is in the middle because it's a point-to-point. You only need 2 usable because it's just point-to-point link. So 255. And this is a mask, it's a /30, which gives you 4 usable addresses. 4 addresses, 2 usable, sorry. No shut, bring that up. Okay, configure router 2, interfaces. Enable conf-t, SE000, IP address 92.168.194. And that's the second usable address in that subnet. In the 192.168.1.192 subnet. 255.255.252. So that's a /30. No shut. Interface FA00. That's this interface right here. Okay. IP address, and this is the 128th network, so IP address 192.168.1.129. So it's the first usable address in that 128th network. So 255, and that's got a subnet mask of 3255s and 192. So that you can see that it's /26, so the first 2 bits have been turned on in that first octet. It's 128 plus 64, 192. So no shut. And lots of all the waitresses PC here. IP 192.168.1.130. It's a second usable address in that. Theoretically, we could have 62 other hosts connected to this LAN, but 2.168.1.30, 192. Its way out is 192.168.1.129. That's the way out through that there. Okay, so now you can see I've addressed using this addressing scheme here. We haven't configured RIP yet, but I could just demonstrate it's just that these networks can talk to other interfaces within their network. So the 192 network can talk to each other, but you can't talk from network to network just yet. So what we're going to do is go into this router 1, go into router RIP, and what we want to do is this router here, it can see this network already because they're directly connected. So advertise the networks that this router can see. 2.168.1.0 network and the network 192.168.192 network. Okay, so this is RIP version 1 so far. This is what I'm configuring RIP as version 1 right now, just to demonstrate. Router RIP network, and this router can see the 192 network and the 128 network, so we want it to advertise those two networks. 2.168.1.2 and the 128's network. And okay, so as RIP version 1, because it doesn't support this VLSM addressing scheme and it automatically summarizes networks at the boundaries, it can still ping within the network, within specific networks, but it cannot ping from network to network. So what we do is we'll check out the routing table just to show IP route. So you can see here that router 1, it's got this network directly connected and it's got this network directly connected, but there's no router RIP yet. It can't see that route. So what we do is conf-t, go back into router RIP and upgrade it to version 2. Do the same on this router 2, conf-t, router RIP version 2. Let this converge, and we should be able to ping. Okay, so we can ping both ways. The waitress can talk to Charlie. Well, she doesn't want to talk to Charlie, but okay, we'll check the routing table again, see what's going on. Show IP route. We can see that RIP now, this router here has got a RIP route to the 128's network, which is this network here. So you can see it now via the serial link. I guess a few things to note is that RIP is denoted by R. The administrative distance is 120, so that's like the trustworthiness of it. So any other routing protocols that have lower numbers than that are more trustworthy routes. You can see the hop count here is 1 because we've got 2 routers and it's just 1 hop across to get to that network. So I hope you've learned something from this video. If you have any comments or questions, feel free to leave them down in the comment section below, and thanks for watching.